Hello, welcome back to LeetCode Daily Live, where I do the LeetCode Daily question raw and uncut. So let's get started. So today we have another medium. The question is construct smallest number from di string. So we have to find out what di string is. So we have a zero index string, so a pattern here of length n, and the length. Okay, we have another exponential problem, I think. Like the bound is very small here again. So we have 8 here. The pattern consists of only, right, so di string means that the string only has d and I think. So let's see what it wants. So, well, I means increasing, d means decreasing. And a zero index string num of length I plus 1 is created using the following conditions. So we want to generate a string called num, and num has to consist of the digits 1 to 9. So, and each digit can only be used at most once. So I think this is where the 8 comes from, and I'm guessing like every time you increase, because the we're looking at every adjacent pair, right? So if there are 8 at most, that means the longest num's length should be 9, I think. So right, and when we see an I, that means num I has to be smaller than, so like we can do like 1 2 2 5 or like 6 8 as long as it is increasing. If it's decreasing, it's the other way. So like 3 2 6 1, as long as it is decreasing. So we want to return the lexicographically smallest possible string. So again, we should definitely try from this like as small as possible. So we want to try like for the, let's say for the first for this first item, we should try like 1 first, and then like we go with 2, go with 3. So this is very similar to the question on Saturday, where we have to like basically use backtracking again, and we keep track of which number we have used already. If that path doesn't work, we remove the numbers back, and then when we found the solution, well, because we are going from smallest to largest every time, we guarantee that it is the smallest that we have found. So yeah, so that will be the algorithm. We should still look at the example and see. Well, does it guarantee that? Does it guarantee that it always works? I think intuitively there should always be a solution. Um, like the most extreme cases are like if they're all increasing or if they're all decreasing, and I think like you can just swap decreasing and increasing to get the results. Like I'm just thinking of a very fake proof, but yeah, I'm pretty sure there's always an answer. Yeah, so if it is this, we want to increase like 3 times and decrease, and then we want to increase and then decrease again. Yeah, so this definitely looks like backtracking, and we would just like use the function again, just like on Saturday. Oh, is it Saturday or Sunday? I forgot, but it's like either 2 or 3 days ago. Yeah, so let's get started, I think. So we need to first find the length of the pattern. Maybe we can call it pattern length. Yeah, and then we want a scene array, a scene set. So every time we have seen a number, we want to add it in, and whenever we go to an empty slot, we just want to try from 1 to 9. And because we are going from 1 to 9, like we are doing a loop from 1 to 9, we can just check whether like each of the numbers in the scene set. If it is not, that means it is the smallest available number we currently have. So Let's do backtrack. Yeah, let's do backtrack. What do we need? I think we just need the index, and then at the end we want to return whether there is actually a solution, and if there isn't, we return false. So so what do we want to do? So for I in range, we want to go from 1 to 9, right? Oh, we also need the array to actually store we actually want to store the number. Like, we actually want to store the nums array, like the result nums array. We'll store it as an integer for now. We'll just map it into a string later on. But yeah, let's just do nums here. Yeah, let's do that. So what is the base case? So we want to just run like this, right? 0. Like, we want to start at the beginning, and at the end we should have nums filled in. So we can just do return. I think I can do join map. So we want to map all the integers from int to string. So we want the string function. We want to map nums. Maybe we have to turn it into a list. I think let's turn it into a list, just for convenience. And well, that should join like all the nums that are turned into a string into one concatenated string at the end. Yeah. So let's just deal with the logic in the backtracking algorithm. So if I in scene, if we have seen that number, just want to continue. And of course, at the end, if nothing works out, well, we just want to return false here. So otherwise, so when we get here, we know that the number is seen. But we have to check whether it is a valid number. So like, you have to remember that like from the previous number. So let me draw it out actually. So let's say it is IID, and if we have, so like this will be 1 to 4. Actually, just one very quick fix. It shouldn't be 10 here. It should be, I think, the pattern length plus 1. So wait, if the pattern has 3 things in it, that means we have 1 to 4. So maybe we actually need to do plus 2 in this case, right? Yeah, I think that's correct. Well, because pattern length is 1 shorter than nums, and we are 1 index, so we need to add 2 here. Yeah, but my point is, if we choose 1, maybe I'll use like DDI. If I choose 1 at the beginning, well, I can't choose 2, 3, 4 anymore, right? Because like for our rule, we need to make sure that this number is bigger than the next number. So it's just that we have to be mindful about. Yeah. So we also have to check. So if index is not equal to 0, so well, for the first element, there's nothing to check at the back, so we just don't do anything. And well, we have to make sure that okay, let's think about the logic. So if we do pattern index -1, it will get the pattern we want, and we also want the previous number. So actually, let's do it like this. So if index is not equal to 0, and if index 1, like the previous number, we don't have to check for equality because we can only use each of them once. Yeah, so if it is smaller than so if the previous number is more than I, but for the pattern, it is actually decreasing. Well, we want to continue because, well, like the rule says that it has to be decreasing, but our current number is bigger, so there's no point dealing with that. We also have to check, so elif. So what if the previous number is larger than the current number that we're looking at, but the pattern is actually increasing? Well, again, we don't want this case as well. So here, when we reach here, we have got to a number that hasn't been seen before, and also checks out with the rule here. So that means we can actually try to add that number in. So we can do nums index equals. Do I have to? Yeah, maybe I want to set all of these to -1 first. For in range pattern length +1. I think we want to do that, and then here we'll do length of nums instead, just to be a bit more concise. Yeah, so we have -1 here, and then like that should set that, and yeah, so we want to set like nums at the current index that we want to set. We want to set it to I, and then we want to do backtrack like on the rest. So we do we want to look at the next thing, but before that we should actually add I into the scene set, because we have now used the number. And well, there are two outcomes with do backtrack, right? So if it is true, well, we can just return true. So like if this returns true, that means we found the solution, right? So well, we can just return here. We already found the solution. Otherwise, we want to set it back. Maybe let's make a constant here, just be a bit clearer again as well. So nums index, set it back to empty, and then we want to remove well, I. And then, well, we try the next number, see if it works or not. If it doesn't, well, we can if it doesn't, we can like try the next number and then try the next number until we have no number and it will return false. But there's one last thing we have to do. We actually have to return true. We have to return true if we reach the end. So if we have filled out the whole thing, we should really return true up here. So if index, so when would the number be all filled out? So if we have 4 numbers, it should equal, so if this is equal to length of nums, that means we have filled out the whole sequence, right? Like the whole nums, and we can just return true here. If I didn't miss anything, I think this works. Yeah. Okay. Let's see if it actually works, or did I miss something? Okay, nice, it worked. Yeah, I think this question is, I don't think it is as hard as the previous 2 backtracking question. Yeah, because like it is a lot easier to implement this compared to the other ones. But yeah, it's definitely a very doable question, I think. And well, thanks for watching, and I'll see you tomorrow. Bye.